Now I want to illustrate how we can use this method in a more complicated problem. Suppose I don't have a single conversion factor, but I have several that I want to apply. So for example, if I want to convert 7 days to seconds. Now I could pretty easily generate a single conversion factor, but maybe I just don't want to. I do have some very well-known facts here. Everybody knows 1 day is 24 hours, 1 hour is 60 minutes, and 1 minute is 60 seconds. So if I want to find out how many seconds are in 7 days, I simply apply conversion factors successively. So I first write 7 days equals 7 days over 1, again emphasizing what's in the numerator. And now I multiply by the first conversion factor, which will get the unit of day to cancel and turn it into hours. And that comes from this one. And that's this conversion factor, 24 hours over 1 day. So I see days cancel as a unit. And now I've converted my days into hours. And now I apply the second conversion factor. And I write it as 60 minutes in the numerator, 1 hour in the denominator to turn the hours into minutes. And finally, I apply the third conversion factor, which comes from this equivalency, and that conversion factor is 60 seconds over 1 minute, so minutes cancels and turns into seconds. When I collect all these, leaving out the units that cancel, I see I have 7 times 24 times 60 times 60, and the only unit left is seconds. And I find the answer is 604,800 seconds. Next, I want to illustrate how the method can be used to convert a complex unit such as a speed or a volume or a density. Speed or volume or density, we'll take speed as an example, is typically expressed with a compound unit. And so for instance, we express speed in everyday life as miles per hour. And so, which consists of a distance unit in the numerator and a time unit in the denominator. So we'll have this particular conversion problem, convert 35 miles per hour into meters per second. Here are some conversion factors we can use. 1 mile is 1,609 meters. There are other conversion factors that I could use, but this one might be familiar to those of you who run track. 1 hour is 60 minutes. 1 minute is 60 seconds. So these are 3 unit equivalencies that I can use. Okay, so let's set out to do this problem. 35 miles per hour. I write it as 35 miles over 1 hour in this manner that I'm illustrated here. And again, to make sure that it's clear what's in the numerator and what's in the denominator. I multiply by a conversion factor, which comes from the first unit that I wrote down, and that's the purpose of that conversion factor is to get rid of the mile unit and turn it into meters. And so after I've done that, I put 1,609 meters in the numerator and 1 mile in the denominator. So miles cancels. Now my distance unit is in the appropriate unit. Now I want to take care of my time unit. My time unit is in the denominator, and I can use this second conversion factor, 1 hour equals 60 minutes. Now be careful how you write it. I have to have, I need the hour in the numerator to cancel the hour that is now in the denominator. So I write 1 hour over 60 minutes in this manner, and then hours cancels, And at this point, I will have the units I have at this point are meters over minutes. And then finally, the last conversion factor comes from the last equivalency that I have written there, and that's 1 minute equals 60 seconds. And again, I put 1 minute in the numerator to cancel that in the denominator, and 60 seconds in the denominator. When I collect all of these and cancel, showing the units that cancel, notice I have this 35 times 1,609 meters over 60 times 60 seconds. And carrying out that calculation gives me 15.6 as a number, and the unit that's left is meters per second. In my next example, I'm going to convert a density. So suppose I have a density given in grams per cubic centimeter, 1.056 grams per cubic centimeter, and I want to find out how much that, what that mass is in pounds per cubic foot. And this illustrates something important about cubic units. So, in this problem, the conversions I have are listed here. 1 pound is 453.6 grams. We have our familiar 2.54 centimeters equals 1 inch, and 1 foot equals 12 inches. Okay, I start out writing my initial quantity as 1.056 grams in the numerator over cubic centimeters in the denominator. My first conversion is to convert the grams into pounds. I use the first conversion factor, and I make sure 453.6 grams goes in the denominator to cause that to cancel, leaving me with pounds in the numerator. Now I have to convert the volume, the cubic centimeter, in the denominator. And for that, I use this conversion, 2.54 centimeters over 1 inch. And I have the cubic centimeter, the centimeter in the numerator to cancel centimeter in the denominator, and 1 inch in the denominator. Well, when I do this, I have to make sure that I use that I cube that unit, because there are really 3 centimeter units in the denominator here. So I really have to apply this conversion factor 3 times, and that's the purpose of cubing it. If I don't cube that whole conversion factor, I will not have converted all 3 of those centimeter units. So my conversion factor has to be 2.54 centimeters over 1 inch to the 3rd power. When that happens, the 3 centimeter units here will cancel those. And finally, for the last, I have 1 foot over 1 foot equals 12 inches. And again, now I'm going to have cubic inches in the denominator, and I have to apply that 3 times. And so this, the whole conversion factor again has to be cubed. So what I come up with when I collect all the units is this quantity here, 1.056 times 2.54 to the 3rd power times 12 to the 3rd power pounds divided by 453.6 cubic feet. And 65.92 pounds per cubic foot, expressed to 4 significant figures.